This is a revision video about greenhouse gases and global warming. These come up as part of Unit 9 of AQA GCSE Combined Science or Chemistry, which is the chemistry of the Earth's atmosphere, and also again in Unit 7 of AQA GCSE Combined Science or Biology, which is the ecology topic. By the end of this video, you should be able to name 3 examples of greenhouse gases. You should be able to describe what is meant by the greenhouse effect and explain this in terms of shortwave and longwave radiation. You should be able to describe the impact of climate change or global warming on the environment and give 6 examples of how human activities have contributed to the greenhouse effect. Finally, you should be able to describe what is meant by peer review and why this is particularly important for climate change. The atmosphere today is composed of approximately 4/5 nitrogen, approximately 1/5 oxygen, and then very small amounts of some other gases, including carbon dioxide, water vapour, and noble gases like argon. 2 of these, the carbon dioxide and the water vapour, are particularly important because these are greenhouse gases. But what exactly are greenhouse gases and why do we care about them so much? The first thing you need to know about greenhouse gases is that, contrary to how it might sound, they're not fundamentally a bad thing. In fact, if there weren't any greenhouse gases in Earth's atmosphere, there wouldn't be any life on Earth. Having a little bit of greenhouse gas means that the temperature is high enough for life to survive, whereas without them, the average temperature on Earth would be well below 0 and nothing would survive. The problem is that while a low concentration of greenhouse gases is a good thing, the concentration is getting too high, and this is where problems start to occur. In the same way that 1 duvet would keep you warm, but 2 might seem like overkill, and 3 would definitely be problematic, small concentrations of greenhouse gases make our planet habitable, but higher concentrations are leading to global warming and serious disruption of our climate. For AQA GCSE Chemistry or Combined Science, there are 3 greenhouse gases that you need to know the names of: carbon dioxide, methane, and water vapour. You must use the word vapour. Water on its own will not give you a mark in the exam. The next thing that you need to be able to explain is how these greenhouse gases cause the temperature of the Earth to change. The greenhouse gases form a sort of blanket around the Earth. They're part of the atmosphere. When electromagnetic radiation reaches us from the sun, it contains a range of wavelengths. Everything from very large wavelengths like radio waves to very small ones like gamma rays and X-rays. The larger the wavelengths are, the more they interact with that blanket and the harder it is for them to penetrate. So initially, shortwave radiation can penetrate through that blanket and get down to Earth, and the longer wavelength waves tend to be left behind a little bit. When they reach Earth's surface, those waves are absorbed and they lose a little bit of energy, and when they're re-emitted, or in other words given back out again, they have slightly less energy and they're also slightly longer wavelength radiation. Those longer wavelength waves again interact more with the greenhouse gas molecules, making their bonds vibrate. This means that those waves aren't easily able to penetrate the blanket, so they can't get back out. Instead, they're reflected back down to Earth, they stay in the atmosphere, and they warm it up. Overall, the temperature starts to rise, and you need to be able to explain the consequences of this. The first consequence, which is fairly obvious, is the impact of melting ice caps. An ice cap is a sheet of ice up to 50,000 kilometres squared, and it's these melting that we're particularly concerned about, for a few reasons. For one, they're so big, so as they melt, that's a huge amount of water that's going into the sea. That causes problems in terms of sea levels rising and is also going to affect the salinity, which has lots of knock-on effects. Also, those big white sheets of ice act really well to reflect the sun's rays back before they can be absorbed. So as they disappear, this just speeds up the rate of climate change. In the last couple of years, the biology exams have specifically refused to give credit for icebergs melting or just ice melting. Chemistry have been more lenient, but to be honest, why take the chance? Another impact of the melting ice caps is that sea levels will rise, and this of course leads to flooding. The second consequence of global warming is extreme weather events such as storms and hurricanes. You should try to specify these rather than just saying something general like natural disasters, as that could imply, say, a tsunami, which isn't typically caused by climate change. These fluctuations in the weather can also cause crop failures, leading to famine. Finally, we can think about the biological impact, things like habitat destruction and extinction. Again, here there's been some variation between the biology and chemistry papers in terms of what they will give credit for, but essentially you want to choose examples that will definitely be affected by global warming. So talk about polar habitats being destroyed, or the extinction of an Arctic animal like a polar bear. You've probably heard lots of people being concerned about the impact of human activities on the level of these greenhouse gases, and rightly so. In the last 250 years alone, human activities have led the level of carbon dioxide to increase by about 50%. A big chunk of that is because of industrialisation and the fact that we've been burning so many fossil fuels. So that's coal and oil and all the fuels that are derived from oil like petrol and diesel and naphtha, and also natural gas or methane. This could be in cars and lorries and aeroplanes or in factories. A large proportion of the electricity that we use in the UK is generated from fossil fuel power stations. It's not just carbon dioxide we need to worry about though. Methane is also a really serious greenhouse gas, even if it gets less headlines and less time in the news. There are 3 big human activities that are all majorly contributing to methane levels. The first one is cattle farming, and this one you've probably heard of because, well, it's kind of funny to think of. So one of the biggest sources of methane emissions is the fact that where you have cattle, and particularly where they've been fed on grain rather than grass, they basically fart out a load of methane. The second thing that's really contributing to methane levels is rice farming. So in order to farm rice, you need to flood the rice paddy, so their roots are literally underwater. And in those waterlogged conditions, the roots have bacteria living in them, which are giving off lots and lots of methane. Finally, landfill, where things are rotting and breaking down, is another huge source of methane. This is another part of the specification where it's really likely that you get questions about the scientific method. So why do scientists publish their data? Why do people believe them? And so you need to have this idea that there's a huge amount of data and lots of different scientific groups around the world have done the same experiments and have been able to verify each other's data and show that there isn't any bias there and that this is objective fact, that the levels of these gases is increasing and that it probably is our fault and that it probably is going to contribute to global climate change. Now, there are still a few skeptics out there, even within the scientific community, and part of the issue is that people really want us to be able to pin down an exact prediction for exactly what's going to happen next and when and why and how. But we're talking about a really complicated system here with hundreds of different variables, and so it's really hard to produce an exact model. And instead, what we tend to do is simplify our models, but also people maybe speculate about what they think might happen, and there can also be some biased opinions. And sometimes the media really feeds into this because although sometimes they can report really fairly both sides, sometimes they'll give 2 sides of the story and make it sound like they're equally valid, when on one side we have 99 scientists with lots of data, and on the other side we have one person with something that's just their opinion. So it's really important that wherever possible, we look at the actual scientific data. Thank you very much for watching, and I hope you found that a useful introduction to greenhouse gases and global warming. If you did find it useful, then don't forget to like and subscribe for more GCSE science videos coming soon.